Hi everyone, so now we're doing class number 2, capital budget applications to tutorials. So we're gonna go through an example, which is the Alaskan Hotel Project. So we're gonna go through a whole bunch of stuff, looking at things like the discount rate, NPVs to get multiple IRRs, to get the NPV profile, look at using things like the solver to work out which project is the best. So the whole goal over here is that we're going to work out things like how many IRRs does the project have, what are they, and would you invest in this project at a 28% financing rate, which is pretty high. Other things we're going to look at is which project is better, okay? Calculating the NPV of different projects with various discount rates, the range of discount rates which will allow you to actually prefer project A or project B, and what range of discount rates would result in you not investing any money. So the first exercise is pretty simple. What happens is that should you do this project, okay, with a 28% discount rate, and these are cash flows. Year 0 is 500,000, year 1's 1.7 million, and year 2 is 1.4 million. So now our goal is to work out how many IRRs does this project have, okay? So what we can do to begin with, we can actually just go that let's look at IRR. Let me click enable editing. Okay. Oops. All right. Disappeared when you do that. Why? Okay. So what we do, let's zoom in a little bit and let's go here. Okay. So IRR1. So we kind of look at this and we know there's positive and negative cash flows quite large. There's a possibility this thing has more than one IRR. So let's do the simple thing, which we kind of go, that is the two cash flows minus 500,000. That's the five, let's see, of that. It gives us IRR of 40%, right? Okay, all right. So basically what happens is that, so basically we use the IRR and it tells us the first is 40%, okay? But we can also use the IRR to actually perform the guess, okay? So that means we can put something which is above 40, let's say it's 50%, and let's see, oh, and it guessed something else, which is 100%, right? Okay, so that means this actually has two IRRs. Okay, so what happens over here is that we need to actually understand that if the internal rate is 40%, 100%, would we invest at this project at a 28% financing rate? Okay, so another way of actually doing this, okay, is actually looking at the the net present value, right? Or we can actually look at something like getting the NPV profile, which is what we're going to do right now. Okay, so we have 0, 10, 20, 30, so on and so forth. Let me just highlight all of them and make them percentages. That would be 0, 10, 20, 30, 40, 40. Get a whole bunch down here. Okay, and we go equals to NPV of, it's going to be okay, it's going to be equals to NPV, right, times the rate, and these are the cash flows, right, and minus, plus 500,000. Okay, so that is check. 1, 2. It should be that here. Okay, so this is going to be, stick to that one, and these things should change, and B4 is always going to be constant, right? So this is going to be dollars, and we bring that one down to here. Okay, so what we actually have, this is the NPV profile, right? So we can also go and we can actually plot out the NPV profile here. So let's select these two, and then we can go insert, recommended charts, and we have this one here. So that shows us that this is NPV profile, okay, which indicates to us their true IRRs, which is 40% and 100. So basically, if we want to look at 28%, that gives us a positive IRR, so we should invest in it. The other way of doing it is obviously getting equals to NPV, okay, and we would go the rate, 28%, these are the cash flows, okay, and we go plus this guy, okay, so this NPV is positive, so we invest, okay, and so we verified this in two ways. One is using the NPV formula, and also using the NPV profile curve as well. Okay, so that's for exercise 1. So now let's look at exercise 2. Now in exercise 2, we have a discount rate of 20%. We have two projects with different cash flows, A and B, and basically A is cheaper and it pays out negative 6,000 over time. B is 50,000, pays out negative 50,000 over time as well. And they last for year 0 to about 6 years. Okay? So now we need to calculate the NPV of both projects using various discount rates. All right, so what are we going to do with this? Okay, so the first thing we're going to do is that, let's say we have the discount rate. Okay, and we have 0. Let's select all of that. We have 10, 20, 30, 40. Let's just bring it down to 100. Strange. 100, there we go. Okay, and what we're going to do is going to get the NPV of A and the NPV of B. All right, so equals to NPV of the rate, which is here, and all of these values here. And what I'm going to have is I'm going to have fixing the rows and fixing the rows of that one too. Okay, so let's see. Oh. Okay, so what happens, we have the NPVs of all these payments and then the initial cash out, and at the discount rate of 0%, we bring it all the way down. Everything's looking good, okay? And we do the same for NPV, equals to NPV of that rate. These values are going to be the cash flows over here, okay? And then plus 50,000. Okay, so we need to fix some of the stuff here, which is going to be fix the rows, except for this, and we get this number is that. Okay, would I mess it up? All right, so that should be not full. Okay. Okay, so basically we have the discount, the NPV, the NPV profiles for A and B, right? So what we can do now, we can actually select all of that, insert chart, and really strange how I don't understand why it doesn't seem to be intuitive to okay, so now we have this chart over here, right? Which actually gives us that these are the NPVs, right? So now we have the NPV profile, okay? So what happens over here is that we can actually get things like we found the NPV of both projects using various discount rates, okay? So where would we prefer A? We would prefer A when it's actually above, like, let's see. So basically, B is actually preferred, A is preferred, okay, up to about 20 something percent because it has a higher NPV. And then B is preferred where the discount rate is actually higher than 20 something percent. Okay, so basically that's what the NPV profile tells us. Okay, so we're going to find the intersection point between both, right? So the other ways we can do that is looking at the IRR, right? So we said the IRR is where the NPV is 0. So let's have a look at that. Okay. So what it actually tells us is that the point in which NPVA, the blue line, crosses that point is about 15%. The point NPV crosses the x-axis is about 20%, right there. Okay. So what happens over here? You can actually work out what the NPV is of these projects as well. Okay, at a discount rate of 20%. Okay, so equals to NPV of the rate of that, and we have all these different and okay, so basically what happens is that okay, so what we see over here at a discount rate of 20%, okay, we would still prefer to go with project A, okay, because project A has a higher NPV, right? So what happens is that if we actually want to work out, okay, what the different where they actually start to change, let's look at the difference in the cash flows. Go equals the IRR of this stuff. Okay, so what we actually find over here, okay, is that this is actually where they intersect. 23.51 when we look at differential cash flows. Okay, so if the discount rate 20%, you still invest in project A, and that corresponds to here because A is higher than B. Okay, at 23.51, that would change. You would prefer to actually invest in B than in A. Okay, So what happens is that the intersection point is 23.51%. If discount rates are greater than 20.51, invest in B. Okay? If discount rates are less than more than 15.34, right? But less than 23.51, then invest in A. Okay? If discount rates are less than, don't invest. So what we're saying over here is that you can see that below this point, both A and B are negative. Okay? So at this point, B becomes negative. So basically, this in-between area is where you would invest in A. All right? Above 23.51, you would definitely invest in B. And less than 15.34, you would invest in anything at all. Okay? So that's pretty much how we actually use things like the IRR, the NPV, and the discount rate. And we can see how all of these actually correlates with each other. So having the graph really helps, mainly because it gives you a graphical way to analyze NPV versus discount rates. So even though we can actually use IRR to work out the different parts of the line, like the intersections and the boundaries and so on and so forth, I highly recommend we always use and actually have the NPV profile so we can actually have a graphical representation of what is going on. Okay? So basically, this just lets you look at really easier. This is just a bunch of numbers. And if you're presenting to a board, right, they want to know the precise numbers, but this graph makes such a big difference because we are graphical creatures. Okay? So one more time, I'd like to iterate. IRR for project A is the point in which the NPV crosses the x-axis. 19.91 is the point at which project B crosses the x-axis. The intersection between A and B is given by the differential cash flows. We use IRR on those differential cash flows, which is 23.51. Okay, based on this information, right, that's when we had, if discount rates are more than 23.451, invest in B. If they are less than 23.51 but more than 15.34, invest in A. But if it's less than 15.34, then don't invest at all. Okay, because B only becomes worthwhile if it's more than 20%.